Hello, my name is Alex. I am a tutor at the Center for Academic Achievement here at East Tennessee State University. I'm an undergrad student, a mathematics major, hoping to become a high school math teacher one day. So today I'm going to be doing a video on limits, just a brief introduction to expose you to them, hopefully explain them a little bit better, and give you insight as to what you might expect a professor or teacher to ask you about limits. So first, let's start with this concept. Say that we have x over x. Well, we know that that is equal to 1 because any number over any number is equal to 1 over the same number. Say that we have x squared over x. We know that that is equal to x. But what happens when we get something that looks like this? Well, you would assume this would be 1 as well, but the issue is that when x is equal to 1, we have a 0 on the denominator. And to quote one of my mathematics professors, the entire establishment of mathematics collapses on itself. So what's the deal here? What do we do whenever x equals 1? What if we need to find out what x is as it gets really close? What do we do? Well, this is where the concept of limits come in. So exactly what is a limit? Well, a limit is basically a word in math that means as approaches. So, we'll see things like this. The limit as x approaches 1 of x minus 1 over x minus 1. What's that mean? Well, it means that as x approaches 1, what is it getting close to? What is the y value getting close to? So how do we find these things? Well, there's a few properties of limits, and the first thing that we need to know is that a limit exists. So we'll say the limit as x approaches a exists if the limit as x approaches a from the left, this little minus sign means from the left, is equal to the limit as x approaches a from the right. And the little plus sign means from the right. So what does this look like in an actual math problem? Say that we have the equation y equals x squared. And the graph for y equals x squared looks something like this. It's a terrible drawing of it, but it looks something along these lines where it's centered along the y-axis. So let's say that we're trying to find out, does the limit as x approaches 0 of x squared exist? Well, using the definition that we just made, what we would try to find out is, does the limit as x approaches 0 from the left, does it equal the limit as x approaches 0 from the right? So we would look at x as it's coming from the left side of 0, 0 being right here. So we're looking at it as it's getting closer to 0 from the left. The graph is continually moving down and towards the center of the y-axis. And as it gets really, really close to 0, it becomes, well, 0. So this right here is equal to 0. As the limit of x approaches from the right side, we see that it's also drawing closer to 0. The y value gets closer and closer and closer to 0. So because these two things are equal, yes, the limit does exist. Now, a lot of times professors will try to ask you questions like this to test your knowledge of limits to see if you really understand it. Say that we have a graph that looks like this. And let's say that right here, this line right here, is x equals, a little better, x equals -1. Okay? Does the limit as x approaches -1 exist? Well, let's look at it from the left and right. From the left, it's approaching some number up here. Some number up here. As it approaches -1 from the right, it's approaching some number down here. So they're not approaching the same y value when they come to this point of -1. So this limit does not exist. Well, what about this? Say we have one that looks like this. And let's say this number is x equals 3. Does the limit as x approaches 3 exist? Well, let's use this same simple rule we've been using. As x draws from the left, it gets closer and closer to this number, whatever it may be. So let's just say that this number is 1. Let's say this is y equals 1. So it gets closer and closer from the left to y equals 1. Let's say that x from the right, we follow it down, and it's also approaching this number. It's also approaching y equals 1. So the right and left hand limits, what they're normally called, as x approaches 3 from the left is equal to the limit as x approaches 3 from the right. And since they are equal, this limit does exist. And the limit of this graph approaches 3 is equal to 1, because that's what we said that was. So even though there's not a value there, even though there's a hole in the graph and the value is actually somewhere else, we don't care about the actual value. All we care about is as the numbers get really, really, really close to x equals 3, what's the graph approaching? And we see that because they're both approaching the same number, the limit does exist, and the limit, in this case, would be 1. So this is a brief introduction of limits. There's a lot more to them in evaluating them, solving other limits with infinity, or just regular numbers. But if you can remember this concept, it makes everything else much, much simpler. So with that, good luck and go Bucks!